Hello everyone, I hope you are doing well. So in this video, we are going to discuss Leetcode problem of the day, and today's problem is minimum time to make rope colorful, and it is a medium level problem. So the problem says that we have been given n balloons arranged on a rope, and we have also been given a string which represents the colors of each of the ith balloon. So the ith character is going to represent the color of the ith balloon. Now Alice wants the rope to be colorful, and we don't want two consecutive balloons of the same color. Now each balloon has a cost associated to it for removing that particular balloon. So you can see there are two things related to each of the balloons. First of them is the color, where colors of I is going to represent the color of the ith balloon. Now we also have an array needed time, in which the ith position represents the amount of time needed to remove the ith balloon, right? So this is basically the cost. Now we have to tell what is the minimum amount of time in which we can make sure that no two balloons are of same colors, no two balloons in consecutive order. For example, in this particular case, these two balloons were together and were of the same color, so this is not allowed. That is why we'll have to remove one of the balloons. So in this particular case, you can clearly see that if we remove the first balloon, the cost is 3, and if we remove the second balloon, the cost is 4. So if you want to minimize the cost, we would obviously want to remove the first balloon, right? So how can we actually solve this particular problem? This is a classic example of take or no take DP, where you can decide for each element individually whether you want to include it or not include it in the final array. Now there is one more thing, that the colors are only lowercase English letters. So if there are only lowercase English letters, there are a total number of 26 possible colors in this particular case, right? From small a going all the way up to small z, right? These are all the possible colors that we have. Now how can we actually solve this problem? This problem can be solved, as I have already told, with take or no take DP. So I am going to initialize my DP of ij. This is going to be a double dimensional DP, and let us discuss what each of these states are going to represent, right? So I is going to represent that I am currently, that I am going to start from the ith index, and j is going to represent color of the previous taken balloon, right? Now I and j together, I and j are going to represent, so dp of ij, it represents the minimum cost or minimum time if I start from the ith index and the color of the previous balloon was j, right? So this is my whole dp definition, that I have a double dimensional dp, and in which dp of ij is going to represent what is the minimum cost that I'll have to pay if I start from the ith index or the current index, and the color of the previous balloon was j, right? So with this definition in hand, let us discuss what are going to be the transitions, right? So I'm just going to define a helper function. In this, as I've already discussed, we are going to receive two parameters again. So this is also the recursive solution of this particular problem. And first of all, if I is equals to n, that means if we have reached or if we have covered all of the balloons, considering zero based indexing, the last balloon will be at the n minus 1th position. So if I have reached the nth position, that means I have exhausted all the balloons. So if I have no balloons at all, the cost or the time needed will be 0 itself, right? Now if dp of ij is not equals to -1, let's say we stored -1 initially in all of the dp ij, and if it is not equals to -1, that means it has already been computed. In this case, I am directly going to return dp of ij, right? Now what I can try to do is, I know that j was the previous color, so let's say j was previous color, and I can find out current color by colors of I minus a, right? So let's say I have this current color with me. If my current color is equals to previous color, which is j, which is j essentially, right? In this particular condition, I'll have to remove the current balloon. I have no other option. So I will have to remove current balloon, right? I have no other option because I cannot go to the previous balloon and remove it now. So if I didn't remove the previous balloon, I'll have to remove the current balloon, right? Let us discuss what is the cost associated if we want to remove or not remove the current balloon. So I have these two variables, remove or no remove. So if I remove the current balloon, the cost will be, so I have this array needed time of I. So this cost will be added plus helper of I plus 1. And since I am removing this particular balloon, so let's say this is my previous balloon, this is my current balloon, and this is my next balloon, right? So if I remove this particular balloon, what will be the previous of this particular balloon? It will be the previous, which was the previous for this particular balloon, right? It is going to be the same. So now if I don't remove this current balloon, this new balloon's previous is going to be this particular balloon. But if I remove this at all, the previous is going to be the same, it is not going to change, right? So in this particular case, I am going to pass j only, right? Since I have removed the current balloon, the previous is going to be the same for the next balloon as well, right? Now let's say I do not remove, no remove, right? So in this case, no time will be added and I am going to move on to the next item, and my previous color is going to get changed, which is equal to the current color, right? Now, as I have already discussed, if current color is equals to previous color, I am going to set my dp of ij, or let me just directly write it first, dp of ij as remove, because I have no other option. Otherwise, I am going to set dp of ij as minimum of remove comma no remove. If the colors are not same, then I have complete freedom whether I want to remove the current element or not, right? So let me just make some space first. So else dp of ij is equals to minimum of remove comma no remove, right? Now once we have this, we can just return dp of ij and then close this function, right? So this was pretty simple, I guess. Not simple actually, but not very hard to understand as well. So let me just quickly go through what I just did. So first of all, I check my base condition that if my I is equals to n, that means I have exhausted all the balloons. I'm just directly going to return 0. Otherwise, if dp of ij is not equals to -1, I'm just going to return dp of ij. Now coming on to the transitions, I first of all get the current color of my balloon, right? So I have the current color of my current balloon. Now I know that if the current color is equal to the previous color, then I'll have to remove the current balloon. I cannot keep it. So I define two variables, remove and no remove, which is going to store what is the cost needed if I decide to remove the current balloon and if I do not decide to remove the current balloon. So if I remove the current balloon, some time will be added, that is the time needed to remove the current balloon. Now my helper function will be I plus 1, that means I'm going to go on to the next balloon and j will remain the same. I've already explained why, because if I remove the current balloon, the previous for the next balloon is not going to change. Now if I don't remove my current balloon, then I plus 1 is still going to be the same, but my previous for the next balloon is going to change, and that will be the current color of this particular balloon. So if current color is equal to previous color, then I'll have to remove the balloon. I have no other option. So dp of ij is equal to remove. Otherwise, if they are not same, I have the complete freedom to either remove or not remove the balloon. So I will take the minimum of them, and at the end I can just return dp of ij, right? So this was the recursive solution. Now I will show you in my code what will be the iterative solution of this particular problem. So what I've done is I've initialized the n with the size of the colored string, and I've initialized a double dimensional TP vector of size n plus 1 cross 27. Now why only 27? I decided to keep the colors in the range from 1 to 26. So 1 to 26. Why only like this? So that for the first balloon, you see that this particular balloon does not have any previous balloon. So I wanted a value which will never be there in this colors array, right? So let me just explain what I mean by this. So let's say the colors array, this is the colors array. It is actually given in a string format with characters, but if I translate them into integers, it will be something like 22, then 1, then 13, then let's say 18, right? It will be some numbers from 1 to 26, right? So for this particular balloon, I wanted to put some value which will never be in this array. Since all of these values are now from 1 to 26, I can safely put 0 here. Why? So that this color never matches the previous color. This is the reason why I wanted to have a different value. And this is the reason why I shifted all the values from 0 to 25 to 1 to 26. So that I have a 0 free and I can put it at the starting position so that the first balloon never matches the previous balloon, right? This was my reason. So now I am going to have this size of 27. So I'm just going to have this for loop. So you see that this part is actually the same as the recursive part. The only thing that I have changed is I have changed the helper function with dp of I plus 1 j. So you see I have defined remove and no remove. I have defined remove as needed time of I plus dp of I plus 1 j. So I have defined remove here as needed time of I plus helper of I plus 1 j. Similarly, no remove will be dp of I plus 1 and colors of I minus a plus 1. So colors of I minus a will give me the index of each of the colors. So essentially it will give me, for a it is going to give me 0, then for b it is going to give me 1 and so on. But I wanted to shift them one step to the right so that I have 0 free. So that is why I have added 1 to represent the actual color. Now if colors of I minus a plus 1, that means the current color is equals to j, that was the previous color, then I am going to set dp of ij as remove, otherwise I am going to set dp of ij as minimum of remove comma no remove, right? Now coming on to these for loops, I can clearly see that my current state I is depending upon remove and remove depends upon I plus 1. That clearly means that the state I plus 1 has to be computed before computing state I. That is why I have a reverse for loop here. So you see, by analyzing the state transitions, you can simply form your for loops in the iterative DP. Right. So that is why I have a reverse for loop here, and for j it doesn't really depend, because if all the states of I plus 1 are computed, j will be a secondary state and its order doesn't actually matter that much, right? So for j also, j just going through all the values. Now at the end I can just return dp of 0 0 so that I can start from the 0th balloon, and for it I mark the previous balloon as 0. Now this 0 will never match any of the colors of the balloons, and hence the 0th balloon, the balloon at the 0th position will never be same to any previous balloon, right? So this was all about this particular problem. Let me just quickly submit this and show you that this particular code works. So you see it passes all the test cases and the solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and you will reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye.